In Chapter 4, we will be looking at another type of function, actually two new types of functions, and we're going to start with the exponential function. And so in today's lesson, we're going to get an introduction to this new function, the exponential function, especially in terms of graphing it. So let's take a look at it as a parent function. An exponential function is any function in which the exponent is the variable. So notice here, it's not about the base. The base is a number. In this case, it happens to be 2. What makes this exponential is the fact that our x is in the exponent spot. So really, there are several different quote-unquote parent functions depending on what number your base is going to be. Usually the most basic one is to start with a base of 2 raised to the x power, and so that's what we're going to start with today. So as we start looking at possible values to put in for x, we start with a -2 here. Now we have to remember here for a second, what does it mean if I'm taking y equals 2 to the -2 power? Well, hopefully you remember from your previous classes and lessons that a negative exponent is the same as saying 1 over the same expression raised to a positive exponent. So this is really the same as saying 1/4. So when x is -2, y is going to be 1/4. Now if we continue with that same logic then, when I put in -1 for x, then I'm going to get 1 over 2 to the first power, which is just going to be 1/2. Now what about 0? What happens when we put 0 in for x and have a 0 for an exponent? Well, again, I hope you remember from previous courses and previous lessons that any base raised to the 0 power always gives you an answer of 1. And then some of the more familiar values for an exponent: if 2 is to the first power, that will give us 2. If 2 is to the second power, that will give us 4. And if 2 is to the third power, then that will give us 8. Okay, so these are the points that we want to graph. -2 1/4, -1 1/2, and so on. So when I plot those points, my points end up looking like this. And when I now draw a smooth graph through those points, my graph will look like this. So this is the general shape of an exponential function. And one of the things that is a bit unique about exponential functions is whether your graph is going to ever touch the x-axis. So if you think about this for a minute, if I have 2 being raised to some power, is there any value of x I can put in there that will end up giving me 0 as an answer? Because if I have a point somewhere on my x-axis, then that means I had a y value of 0. So I would need to have 2 to the x power end up giving me an answer of 0. And hopefully you realize that the answer to this question is no. There is no value that I can put in for the exponent here, where x is, that's going to end up giving me a 0 as an answer. Okay, so one of the things that is unique about the exponential function is that there seems to be this horizontal asymptote that prevents the graph from going below a certain point. And that's going to be useful to us here in just a minute. So let's do a function analysis on this new function of ours. So using the 2 to the x, we want to start with the domain and the range. So going back to our graph here, what values can be used for x? So what values can I put in for x in the exponent for this function? Or another question is, what values do I see on my graph as x values that could be used in my graph? Well, there doesn't seem to be any limit to how far my graph could go this way or how far my graph could continue to go in this direction. It would keep getting steeper and steeper and go pretty high, but I could still continue to choose x values that were bigger and bigger. So that must mean that my domain is going to be all real numbers. Now what about my range? What about my y values? Well, as we just mentioned, there seems to be some limit as to how low my graph can go, and therefore there would be a limit to what my y values could be. So if my graph cannot go beyond this x-axis, then I must have to keep answers here that are positive. So all of my y values have to stay above the x-axis, which means they all have to be positive answers. So in interval notation, my domain would be negative infinity to positive infinity, and my range would actually only go from 0 up to positive infinity. And notice here I'm using the open parentheses, the rounded parentheses rather than the bracket, because we just said our graph is never actually going to hit the 0. It's never actually going to touch the x-axis. So 0 is not included as one of the y values, but anything greater than 0 could be. Now what about x and y intercepts? Well, again, if we go back and look at our graph, I'm sorry guys, I missed a slide in here. So let's just do this quick. Remember our graph looked something like this. Okay, so again, if I can't cross my x-axis, then that means there's no x-intercept. But what about the y-intercept? If you look on your own graphs that you've been copying as you watch this, where is the y-intercept going to be? Well, hopefully you realize that it's at 1, because anytime I put 0 in for x, I'm going to get a 1. And really this doesn't matter what the base on my exponential function is. This is always going to be the case, because any base, again, raised to 0 power will give us 1. All right, now how about the next two categories? Is my graph increasing or decreasing, or a little of both? And are there any max or min points? So here, when I look, you can see if I were to start on this end and just follow my graph from left to right, my pen is going up. So as I move from left to right, my graph is always increasing. And if I could start further out, or if I could continue to keep going up here, I would always be increasing on this graph. Which really tells me two things. It not only tells me that I'm always increasing, but it tells me that there's no place where this turns around to start decreasing, so there's no max or min point. Now, for symmetry, remember there's two types that we look for. We look for symmetry with respect to the y-axis, so the left side is a reflection of the right side, or we look for symmetry with respect to the origin. So when you look at this, it's pretty obvious that this side of the graph is not a reflection of this side of the graph. Okay, so we certainly do not have symmetry with respect to the y-axis. Now for the origin, remember the way to tell if there is symmetry with respect to the origin is to turn your graph upside down and see if you end up with the same looking graph as what you did originally. So let's do that. Let's turn our graph upside down. Oops, goodness, I've missed some slides in here, so we'll make do. So if I turn it upside down, if you can kind of imagine literally taking your graph here and spinning it around 180 degrees, then I'm going to end up with a graph that looks like this instead. Now, does that yellow graph look like the original graph? Obviously no. So if it doesn't look the same, then there is no symmetry with respect to the origin. So our answer for the symmetry box is none. Now, finally, if we look at our last two boxes, do we have any asymptotes, and what is our end behavior going to do? So we've already mentioned this. We do have this horizontal asymptote that limits how far down our graph can go. We do not, however, seem to have any vertical asymptotes anywhere. There's no limit to what we can use for x values. So no verticals involved, just this one horizontal. And in terms of the end behavior, it is this end that is getting closer to that asymptote, whereas this end just continues to increase unbounded. So for our final two spots here, we would say we have a horizontal asymptote of y equals 0, which represents our x-axis, and as our x value gets closer to the negative values or moves in that direction, then that's when our graph is getting closer to the 0, whereas when x gets bigger and bigger, then our answers just take off unbounded and approach infinity. Okay, so with that information in hand, we should be ready to talk about the activities that you did in class and to kind of tie all of this together in our next class, looking at this idea of exponential functions and looking at the kinds of results you got in your activity. So, in class, be ready to pull this all together and ask lots of good questions, and we'll see you then.